Let's start with HyperWorks CFD. Importing geometry. Edit the geometry. Define flow physics. Multi-fluid type will be bidirectional EDEM coupling, since we have a two-way coupling with the DEM solver, which is EDEM in this case. Adding a new material. Choose appropriate to drag, lift, and torque models. Run the case for 20 seconds. Four iterations per time step. Verify if the material is the material that you've created. Inlet normal velocity of 17 meters per second. Inlet normal velocity of 1 meters per second for this surface. Inlet normal velocity of 1 meters per second for this surface. This is the spray nozzle. Outlet boundary condition at this surface. A no-slip boundary condition for the draft tube. All the 6 surfaces. Right-click to show all. Mesh refinement necessary in some surfaces. A smaller mesh required on this surface. A mesh refinement zone to be created. create another refinement zone. Right click and hit the green tick button. Volume mesh. When the state of the green check mark, the mesh is complete. Verifying the mesh. There are multiple elements. Export the solver deck. If you look at the directory, there is a directory called EDEM created, and there are all these files created inside that directory. Let's open EDEM. If we go within that directory, let's create the bulk material. Define the interaction parameters. Create a particle. Create a new bulk material for the spray. Defining the interaction parameters. Create a spray particle. Define the equipment material. Define the interaction parameters with this equipment material. Create a geometry for pellet creation. Move it to the required location. Add factory. Change it to a static factory. Verify if the material is the pellet material. Save the model. Save interval, total time step. Use a GPU solver with double precision. Auto update is enabled so you can see how the particles getting created and falling inside. Simulation is finished. The creator, I just want to note that when a factory is created, make sure that the type is virtual and not physical. Otherwise, this geometry or this cylinder will be a part of the geometry which can interact with the pellets. So now that the simulation is completed, let's move on to the analyst, which is the post-processor. Reducing the opacity of all the equipments and looking at the animation. Now let's save the simulation deck. This deck will be a starting point for our CFD-DEM coupled simulation. Let's save it in this demo directory. Set the simulation time to 0. Let's open that deck. As you can see, the particles are created at 0 time step. Let's go ahead and define the spray. Make a copy of this geometry. That will act as our spray factory. Again, make sure the type is virtual. Add a factory. We want unlimited spray coming up with a target of 7 million particles per second. Let's start the spray at 1 second so that the particles are fluidized until then. The pellets are fluidized until then. Make sure that the material is set to spray material. Next, the velocity of the spray needs to be set to spray. Defining the spray direction. The spray velocity is 15 meters per second. In the physics, make sure to add the spray coating additional model available. Define which is your spray material. The particle to geometry physics also add this spray coating additional model. Again, define which is your spray, particle body force, add the spray coating update additional model. Now save, move to the simulator. Make sure that the EDEM time step, make sure the multiple of an EDEM time step is equal to the CFD time step of AcuSolve, which means that since CFD or the AcuSolve time step is 5e minus 4, the EDEM time step is 5e minus 6, and which is a good ratio for a CFD-DEM coupled simulation. 100 DEM time steps equals 1 CFD time step. In this case, total time is irrelevant because the total times is calculated, or the final time is calculated from what is specified in the AcuSolve solver, and it does not take the EDEM final time. Target save interval. Once these settings are set, activate the coupling server with this button. As you can see, it says awaiting client connection. Go back to your AcuSolve model. Set a problem name, problem directory, the demo directory. AcuRun path needs to be where you have installed AcuSolve. Choose AcuRun. Parallel processing with 12 processors, and run. Right click view log file. As you can see, connecting to EDEM successful. So the connection between EDEM and AcuSolve is completed now. And now, as you can see, EDEM is communicating with AcuSolve for the solution. Client connected. So this simulation will take a couple while to finish. So I have a completed simulation right here. And if I reduce the opacity, as you can see, the spray and the pellets are in this animation here, which is getting coated, but it's not a good representation. So let's color the particles for better understanding. Spray. Let's color the spray particles to a red color. Let's color the pellets by the volume added, and let's use red color with a legend. Right. So now, if I reduce the opacity a little more, and then play the simulation. Since we started the spray at 1 second, at 1 second is when the spray will come up. As you can see, there's varying degrees of coating for each of these particles. A more better representation would be a sliced representation, because right now the particles inside of this clump are not seen. If I go to clipping, enable clipping, so this clipping plane was already created, but to create a new clipping plane, just hit this plus button. Again, at 1 second, the spray will start. As you can see, with time, more and more particles get coated.